All right, thank you, everybody. We'll go ahead and get started. I'm Sarah Brewer. I'm the director of our education program at Accords. I want to welcome everyone to today's education program seminar. So what is Accords? For those of you who don't know, I think I see a lot of familiar faces here in the room and some names on the Zoom. Accords is supported by the University of Colorado School of Medicine and Children's Hospital Colorado. It's a unique one-stop shop environment for faculty to conduct pragmatic research, receive various types of services and support for grants and projects, and also get incredible mentorship, training, and education in health services research. Accords conducts pragmatic research in a real-world setting to improve healthcare and outcomes by providing a multidisciplinary collaborative research environment, strong methodological cores and programs, and I want to highlight our biostatistics and analytic core that's partnering on this particular seminar series. I also want to point out to folks, we have a couple of new cores started over the last couple of months. So we have a new learning health systems core and a pragmatic trials core. So if those are areas you're interested in, we have new resources to support that. We also provide consultations for grant proposals, mentorship training and support for junior faculty, and extensive educational opportunities, both locally and nationally. Just to point out some upcoming educational opportunities. Next week, we have our Accords CCTSI Community Engagement Forum. In November 1st, we are kicking off our shared decision-making series for the year with ethical issues in shared decision-making. November 9th and 16th, we have our first ever overview of dissemination and implementation science workshop. The end of November, the next in this series on statistical methods for pragmatic research, we'll have Dustin Rabideau. And then in December, we have the second in our shared decision-making series and fourth of this series with Dr. Maren Olsen. So before I introduce our speaker today, just a couple of housekeeping items. First, if you are on Zoom, please go ahead and use the chat or the Q&A function to share any questions or comments you have. We will have plenty of time to address those in the hour. And then second, as you get closer to the end of the hour, please take the time to fill out our evaluation. This really helps us to continue and provide the best educational offerings for all of you. Today's seminar is part of our Statistical Methods for Pragmatic Research series. It's the second of 9 in this series. And today we welcome Dr. Heather Smyth. Dr. Smyth is a research associate in the Center for Innovative Design and Analysis in the Colorado School of Public Health. She's a collaborative team scientist and provides biostatistical support for a variety of research projects within Accords, the CU College of Nursing, and the Rocky Mountain Prevention Research Center. Trained as a quantitative psychologist, her methodological expertise uses mediation and moderation, causal inference, psychometrics, and latent variable modeling. Dr. Smyth is also interested in the statistical and study design issues related to health equity in the LGBTQ+ community and in improving educational pathways for underserved students in STEM fields. Please join me in welcoming Dr. Smyth today. She presents a reintroduction to statistical mediation. Welcome.
Okay, now the next slide is already there. Jordan and Sarah have done such an amazing job preparing this and making it easy to be a presenter. So just want to acknowledge all of that hard work. So yeah, Sarah, thank you for that introduction. So I realized that this topic may be a little bit of a review for some people. It may be something brand new for other people. And so my goal today is to kind of keep it kind of short and simple, talking about some of the broad themes and broad strokes and really taking a more conceptual view of some of these things. There are a lot of technical weeds that we could get into, and I would be happy to do that with anybody. This may not be quite the right venue for some of those things, but we'll see what kind of questions come up. And see kind of where we need to go so that you guys can feel comfortable using mediation in your pragmatic research. So I think Sarah really covered everything that would be on this slide. I do want to point out my mom thinks that she tells all of her friends that I am a quantum psychologist. I am not sure what she thinks I do for a living, but I hope it's very, very interesting. But you didn't come here to learn about me, as interesting as I am. We're here to talk about mediation. So just a brief overview. I kind of want to set the stage for why I'm here and why you're here and why we're talking about mediation. And like I said, I kind of want to keep some of the definitions at a higher, more conceptual level so you can feel comfortable understanding why you would want to do a mediation analysis. A comparison of mediators versus a lot of the other types of variables that are out there, because that is honestly the most common question I get. Is my variable a mediator or is it a XYZ? Literally an XYZ. But I've kind of highlighted this overview of mediation methods, and that's really where I want to spend the most of our time. I think that's what will be most useful to everybody here and on Zoom. And then we'll just end up with whatever Q&A. So last month, Dr. Colburn introduced us to the NIH stage model, which is it's a framework for developing behavioral interventions. So it's something that's near and dear to the heart of pragmatic researchers. And it starts with, just your basic research, generating your intervention, testing the efficacy, both in research settings and in more community settings, testing for your effectiveness, and then finally coming up with your implementation and dissemination plans. But if you go to the website to learn about this stage model, you will find hidden in the middle of a paragraph what I think is the most important sentence on that website, which is the examination of mechanisms of behavior change is encouraged in every stage of intervention development. So from stage 0 to stage 5, researchers should be thinking about the mechanisms of the effects that they are studying. As a statistician, that word examination makes me a little uncomfortable because it seems really vague. Like, what do they mean, examine the mechanisms? Like, when I wake up and sit down at my computer, what exactly am I supposed to be doing to fulfill that sentence? And so that's really why we're here today. I want to make it explicitly clear that when you read a sentence like that says, hey, I want you to examine your mechanisms, what is implied is a statistical mediation analysis. And so that's one reason why mediation is so important, because that is an active, it is just a very specific thing that you can be doing to examine your mechanisms. And so I think the best place to start as we move from this idea of mechanisms to actually doing a mediation analysis is to define what we mean when we say this variable is a mediator. If you've ever been confused about that, you are not alone, because the literature there has been a lot of discussion since the 50s. I think a lot of us think it might have started in the 80s, but there's been discussion since the 50s about what mediation is, what a mediator is, how do you define it? And we have conceptual definitions and we have mathematical definitions. And I don't know, people have been arguing for a little while. I'm going to offer to you what has been the most convincing and I think the most useful definition to me. And that is, a mediator is a variable that is intermediate or in the middle of a causal process relating your independent and your dependent variable. If you can think about it like dominoes falling over, or if you play pool, your cue stick is your independent variable and it hits the cue ball, which is your mediator. And then that cue ball hits the 8 ball into the corner pocket. And that's your Y variable, your outcome. So it's literally like this chain of effects. And I want to point out in this definition, I highlighted the words causal process. That is an integral part of this conceptual definition. A lot of people might be more familiar with the Barron and Kenny definition of a mediator, which is just a variable that accounts for the relationship between X and Y. Unfortunately, that was a great place for us to start, but unfortunately, that definition also applies to confounders, and confounders are not mediators. So I would say we've outgrown that original Barron and Kenny definition a little bit. And on the next slide, I'll start going over some of the mediator versus all of the other variables that you might have. Before I do that, I do want to mention just a few vocabulary terms so that you know that if, depending on the field that you're in or the field that you're reading about, if you hear intervening variable, process variable, intermediate or surrogate endpoint, those should all clue you in that we're talking about a mediator. We're talking about something that is in the middle of a causal process. Likewise, people may talk about mediated effects. Some people talk about indirect effects. That should clue you in that we're in the same ballpark. We're talking about the same thing. There are some little nuances to some of these terms that I would love to talk to you about if you're interested, but they're kind of, some of those differences are pedantic and probably not very helpful when you're in pragmatic research and you have a question, you need to know how to ask your question and how to answer it. So that's just a caveat. These are not direct synonyms, but if you hear these terms, know that you are in mediation land. You are in the right place. So like I alluded to, sometimes mediators can be confused with a lot of other variables. So if we take any given research study and we break it down to its most simplest form, what we want to know is whether our independent variable has an effect or is related to our dependent variable. That is a two-variable system, X and Y. Put those two variables together in a regression, get your answer. But when we talk about mediation, we're expanding that model to add a third variable. And anytime you want to add a third variable into that kind of simple two-variable system, there are three possible causal systems. And again, I'm being very explicit about saying the word causal here, because if we incorporate the causal directions between our variables, we have three possible systems. The first is a mediator, and you can see how the arrows go from X to the mediator and from the mediator to Y. The direction of those arrows is important. The next thing you can have is a confounder. And like I alluded to earlier, mathematically, telling the difference between those first two models is pretty tough. Like if you go to your analyst and say, is this a mediator or a confounder? They're going to say, I don't know. Is it a mediator or is it a confounder? That is something that mathematically we can't decisively decide. If you get nothing else out of today, I hope you know that your analyst cannot tell you whether you have a mediator or not. That is something that we work through the theory and the research question. The third possible causal effect you might hear about is a collider. Those are not as common in the literature, but you might hear about colliders more often. And you can see the direction of the arrows there, where your X and your Y are both causing the collider. If you've ever heard of Bergson's paradox, where like this is the classic example where one disease and a second disease both cause you to be in the hospital. And so when you look at hospital patients, you get a spurious effect between those two diseases, because you're not looking at the whole population, you're looking at only those who are in the hospital. And that's how those arrows work. That's just to kind of give you a little bit of a memory trace. Today's topic and focus is really on that first system with a mediator. Again, those were the causal systems that you can have when you add a third variable. You can add third variables or fourth or fifth variables that are not causal, and we don't expect them to be. Our theory does not say that they're causal. Moderators would be a good one. Your covariates, all of your basic, all of the variables that you would include for socioeconomic status or gender or insurance status, all of those things as covariates. Suppressors and distorters, you don't see as much. It has to do with collinearity between your variables. Again, that is a little bit of a technical detail that most people probably don't run into. So I just want to touch on that lightly. And also this idea of redundant measures. Are you actually measuring two different things, or are they the same thing? Just two different researchers have called it two different things and developed two different surveys, but It's really the same construct. So you could have a non-causal variable that is any of those things, and those are not your mediators. So like I said, one of the biggest questions I get is this variable a mediator or a moderator? Can you please tell me? And so I would always go back to the researcher and say, is this variable something that will affect the strength of your effect, but it's not causal? It's not like if I do X, then M will happen, and because M happened, then Y will happen. That's a mediator. A moderator is just, well, this process is stronger for group A than it is for group B. It's not being in group A or group B doesn't cause the effect. It's just that the effect is different between these two groups. You can have a variable that is both a mediator and a moderator. Mathematically, I can't tell you the difference, but if we look at your theory and your research question, that's where we decide how should this variable be specified in your model, and what model and what theory am I testing if I make this a mediator versus if I make this a moderator. I spent about a year digging through the literature for my comps exam to try to figure out that question. So if you want to do some reading, I've got a great reading list for you. The next thing is the covariate. This is a variable that we know is related both to X and Y, but we don't believe that X causes it and it causes Y. So they're related, but it's not causally related. Confounders. This is one of the causal ones, but it's not in the causal sequence. We think that the confounder causes both of them, not that X causes that and then that causes Y. So if you go back to the, even though confounders are causal relationships, it's the direction of the arrows that will tell you whether you have a mediator or a confounder. And then finally, the colliders. Again, we're in that same situation where we have to think about the direction of those arrows. And that's something that your theory is going to tell you whether or not, or maybe it's a time, like this can't be in the middle of the causal sequence because this thing happens before the other thing. But those would be kind of the four most common variables where people go, I don't know if I have a mediator or if I have a covariate. I don't know if I have a mediator or if I have a moderator. And the secret is it part of the causal chain? Ask yourself that, and then you can kind of decide whether or not you have a mediator. Okay, so you know that the NIH wants you to do mechanism exploration, but why are people wanting that? Why would people want to do a mediation model? And really, it's kind of separated into two strategies. One of them is mediation for explanation, and one of them is mediation by design. I would think that mediation by design is probably going to be more common in pragmatic research, and that's where that's the second one, where we know that the mediator and the outcome are related, and so we're going to develop an intervention to try to manipulate the mediator so that we can manipulate the outcome. So the common example, if I know that vitamin C is going to reduce scurvy, I'm going to try to create an intervention so all of my sailors will eat more oranges. And that would be mediation by design. The first one, mediation by explanation, is exactly what it says. I see that there is this relationship between X and Y, and I want to know how or why that association exists. I know there was in my social psych class, there was a classic studies about like the smell of cookies makes people act nicer to each other. And so they would pump in the smell of cookies and study if people were like engaging in nice ways or not nice ways. But they never actually measured how much cookie smell was going on or how the people were reacting. So we don't know, like, they were nice to each other, but why were they nice? Because there's no measurement of the cookiness or how people felt about the cookies or if people felt comfortable because of the cookie smell. And so mediation for explanation would say, okay, we noticed that if we bake cookies, people are nicer to me, but let's design a study so we can say why. I think it's just the smell of toasting flour and butter is the most delicious thing in the world. So I see what, you know. Okay, I'm gonna take just a brief minute and be on my soapbox. Your two best friends in a mediation analysis are your scientific theory and your research question. For my analysts in the room and on Zoom, when your PI comes to you and wants to do mediation, the best thing you can offer them is ask them questions about the theory that they are testing. Ask them to be very explicit about the research question and to make sure that the research question includes that causal process or that mechanism piece. You're not just looking for the associations, but your theory suggests that doing X will manipulate M and cause an outcome in Y. If you are, for my substantive researchers in the room and on Zoom, when you go to your analyst, think about what your theory is that you're testing and expect them to ask you about it, and expect them to ask you what specifically is your mediation research question. I think that veteran status and time in service have an influence on people's health behaviors. Okay, tell me more. That's not going to be a precise enough research question. The math, the statistics, they can't do this work for you. This is not a big data where we can put it all in and the answers come out. We have to apply the theory to the model that we're specifying. Just taking a little bit of a minute there because that's important to me. But now I want to go into kind of that bolded part of the outline. I think this is where we want to spend most of our time today. And that's looking at what are your options. I have convinced you, I'm not going to ask if I have. I'm totally sure that I have convinced you that you should be doing a mediation analysis. If not, NIH reviewers may ask you to do it anyway. So, and so there's just kind of a little bit of a timeline. This is a broad strokes timeline. You could dig deep and find that we've been arguing about this for decades. But back in 1955, Hyman and Lazarsfeld both independently published a description of what they called the elaboration method. This is not necessarily something that you would try to do, but if you read those chapters, you can see that this is clearly a precursor to what Barron and Kenny gave us in the 80s. So I think the Barron and Kenny 1986 is kind of the citation for doing a mediation analysis. And that's where they outline the 4 steps that is known as the B and K method or the causal steps method. If you were to just try to Google, like, I know nothing about mediation, but I want to try to do it, you will find a lot of places that outline this method and say, this is how you do mediation. In the early 2000s, the literature started providing us an even better option. And I call these the coefficient methods. You can have a difference in coefficients, which is directly implied from the Barron and Kenny method, or the product of coefficients, which you will find out later is going to be my general recommendation. But we're now, for about the last 10 years or so, the econometrics and the epidemiologic literature have been putting out the idea of causal inference mediation using something called DAGs, direct acyclic graphs, or the potential outcomes methods. So hopefully those are terms that maybe you have a fleeting memory of. You've heard those terms being floated around. I'm not going to go into a lot of depth with that today because that is a whole semester's course. But that is kind of the cutting edge. And so you may hear reviewers, if they say like, oh, well, why didn't you do potential outcomes? Or have you considered potential outcomes? What they're talking about is kind of this next stage or the cutting edge of mediation analysis. I think the coefficient methods is something that most people could accomplish with the standard statistical training that they have. Potential outcomes is going to be a little bit more of a specialized thing. I highly recommend dipping your toe in those waters. But if that's not a place where you're at, I think the coefficient methods will be a good choice for most people. So we'll start with the Barron and Kenny. I unfortunately still see this a lot in the literature, people doing this method and saying that they're doing the, cutting edge mediation. And the first step is that you just want to make sure that your X and your Y are related. And this is honestly where most people stop with their research. Does my intervention cause a better outcome? Yes or no? And this is my effect size. But then they never go, well, why did it cause that effect? What is the secret ingredient in the intervention that causes that effect? Step two is just making sure that your independent variable and your mediator are related. Obviously, if X is causing M, you should see some kind of relationship between those two variables. You may hear this called action theory. I think that comes a lot from the prevention side and the prevention world. If you were trying to create an intervention, you would want to make sure that your X can act on or manipulate your mediator. So that's step two. Step three, in prevention, we like to call this the conceptual theory. We believe that our mediator does actually have an influence on our outcome. And so you would run a regression analysis where you would control for your independent variable, but you do want to specifically look at that effect between your mediator and your dependent variable. And you can see all of these arrows that I'm drawing can be related to a basic regression model. So the fourth step would then say, so this arrow between X and Y in step one, and the arrow between X and Y in step three should be different. If M is a mediator, then those two coefficients should be different. And so step four is looking, originally it was like the first one has to be 0. How often I actually see the number 0 in the real world. So now it's just, is it less than? The trouble is, I'm going to tout this paper. This is one of the papers that I tell people to go see the most, O'Rourke and McKinnon 2018. The problem with that is that there are specific scenarios where that first arrow, that first effect between X and Y might not be significant, even though we know that the mediated effect is significant. And this table from that paper gives the exact, it looks like there's 5, 1A and 1B, and then 4 specific scenarios where you might have a significant mediated effect, but if you do that, just that direct effect, find that it's not significant and stop, which is what the Barron and Kenny method would suggest, then you're not going to find your mediated effect. And a lot of it has to do with, like, if you have multiple mediators that are operating in opposite directions and they'll cancel each other out. And so that would show up as a non-significant effect between, or total effect between X and Y. If that doesn't convince you, power. So this is a portion of a table from Fritz and McKinnon 2007. And we see that they looked at the Barron and Kenny test. That first column is when the effect between X and M is small, and the effect between M and Y is small. That's what SS stands for. If we assume that there is total mediation and that your mediator accounts for 100% of the relationship, that's what the tau prime equals 0 means. You would need to have 20,886 people in your study in order to detect that effect. That's a lot of people. If you were to look down at the bottom of this table, I think the lowest sample size is 480 something, and that would be using a bias corrected bootstrap method. So some of the more modern methods can improve your power from having needing 400 people to needing 20,000 people. So if nothing else, for the sake of power, stop doing the Barron and Kenny. So what if I've convinced you and you want to move on to a more modern method, what should you do? And that's where we're going to move into the coefficient methods. I think the paper here at the bottom, McKinnon et al. 2002, is a classic citation, and that will kind of give you a good overview of the methods that are available. I have seen a lot of love for the joint significance test, especially in some of the nursing literature that I've seen. It is computationally lightweight compared to a bootstrap method. You could also do the product of coefficients and using something called a Sobel standard error test. I will spare you the gory details of that formula and just tell you that there are calculators online that will incorporate this Sobel test. It is the classic test of how you take the standard error, because you've got two different regression equations, x to m, and then x and m to y. And so you're trying to marry these coefficients from two independent regression equations. And the Sobel standard error test is mathematically a way to do that. And then you can also do the product of coefficients test and do something like either the asymmetrical confidence intervals or bootstrapping. Those are going to be more computationally intensive, but that is not a reason not to do them because our computers are so fast. Like I saw a paper in 2018 that was like, oh, don't do it. It's so computationally intensive. And I'm like, it's 2023. You could do a quick bootstrap. It's not going to burn the place down. So again, joint significance is nice. The idea behind it is that if your relationship between X and M, which is your A path, is significant, and your relationship between M and Y when you're controlling for X, which is your B path, if that is also significant, then we know that there is a mediated effect. That mediated effect is going to be non-zero. And so we just go, A is significant, B is significant, we have mediation. Oh, great. How much mediation? Well, I can't tell you that. All I can tell you is that it's there. You should probably be doing this along with some other methods, or if you have a particularly tricky model, this might be the best you can do. It's out there. It's got great power. Then there's the product of coefficients, either with a Sobel or a bootstrap. The nice thing about this is that we can tell that not only is there mediation, but I can put a magnitude to it. I can literally just multiply my A coefficient and multiply my B coefficient and come up with a number that I can use to describe the magnitude of my mediated effect. There's a whole nother set of literature about what effect sizes you can or should be using. Some of that depends on, do you want to say how much of the total effect is mediated? How much of the direct effect is mediated? Which one of those answers your research question better? So if there's nothing else besides know what your research question is, I would suggest, if you're not entirely comfortable with this, but you know you need to do something, do a product of coefficients method and use a bootstrap standard error. If you can't use the bootstrap, the Sobel is usually fine. I think it's better for larger samples, but the Sobel's fine. If you can do the bootstrap, I would do that. That sounds easy to say, right? Yeah, guys, just go do products of coefficients. You are, I'm not going to leave you hanging. So there is a shiny app that will do the asymmetric confidence limits for your mediated effect. All you need is your A coefficient and your B coefficient. So go into your model, run some regressions, get those coefficient values, and then get the standard errors of those coefficients. You can pop it in here and it will give you the confidence intervals. You can use that to determine whether it's significant. It will give you the size of the mediated effect. I would use this. I use this all day long. Another really great resource I know I've told you to stop using Barron and Kenny. However, go to Dave Kenny's website. It is a good kind of like encyclopedia of information. He's currently updating it. So it's got a lot of the information that I've told you about, links to our packages, links to classic citations. It's just a good kind of encyclopedic resource for getting started with mediation. So definitely go check that out. Just don't use the causal steps. One of the reasons why I like this product of coefficients method so much is that what I've described to you today is kind of the simple base case. You've got just one mediator, one outcome, one independent variable. But we can expand that to having multiple mediators, to having clustered mediators, students in schools, and what is the mediated effect? Longitudinal effects. We want to see if X at time 1 and M at time 2 and Y at time 3. If you have categorical outcomes, instead of doing linear regressions, we can do logistic regressions. We can expand this to all kinds of more complicated models, which is honestly, nobody is running a 3-variable model. We have much more sophisticated research designs these days, and this product of coefficients method can be expanded into that. That being the case, now that we're introducing a lot of complicated and more complex models, this is my second and last soapbox of the day, is understanding the assumptions. Like I said, I've tried to give a kind of a simplistic and a brief overview just so that you know what touch points and what questions to ask. As these models become more complex, it is important to really understand the assumptions that you are applying to your model. A lot of them are just basic regression assumptions, or basic, like, did you randomize your sample? Is things that you would do every day. Specifically, now that we're moving into mediation, there's a few other assumptions we want to take into effect. When my advisor gives this talk, he has 2 pages of assumptions. I have tried to make it less scary, and I'm just going to put it on 1 page for you. But when you set up a mediation model, you are assuming that you have included everything that is involved in that model. You assume that the reality of the world is contained in this X causes M causes Y, plus whatever covariates you might add, whatever confounders you need to add. But you are assuming that you have the correct temporal structure, the correct causal structure. The numbers can't tell you whether you did or not. The numbers can just say, like, I am going to impose this theory and then see if this theory matches my data. But your data itself can't necessarily derive that theory for you, if that makes sense. You're also assuming that your measures are reliable. And especially if we're doing behavioral research or any kind of social science research, that can be a huge problem. Again, our mediated effect is the product of 2 numbers, and those numbers are less than 1. So that number, that value, is going to be small. If you have unreliable measures, you are just taking away from your ability to find that very small number. So it is important that your measures be reliable, and especially the measurement of your mediator. I've mentioned that we're actually using 2 separate independent regression equations. And so when we do that, we assume that the errors from those regression equations are not correlated. And then obviously temporal precedence. If something causes one thing, the causal thing has to happen before the caused thing. I see you chuckle, Sarah. I've had these discussions with people. And then just the measurement timing. I know that there's an unpopular opinion. I know that there's a lot of chatter about it's not mediation if you don't have 3 time points, at least 3 time points. I think depending on what constructs you are talking about, it is important that theoretically those constructs are temporally aligned, but that doesn't necessarily mean that they are measured temporally. So if you have a time invariant covariate, you know, something gender or something like that, that happens before whatever trauma might happen, which you're using for your mediator. But you're not measuring gender when a person either is born or transitions. You're asking them their gender on the first day of your study. So like your measurement timing is cross-sectional, but the construct that you're measuring is not necessarily, like the construct happened before, because it's just a part of their characteristics. So you can do cross-sectional mediation. Don't let anybody tell you you can't. You just have to think a little bit more about what it is you're measuring and how you're measuring it. So that's my unpopular opinion of the day. So at this point, I want to do a quick check-in. I don't know between how much time we have. The next section, I'm going to touch very briefly on the potential outcomes. I don't want to move into that because it is a little bit of a can of worms, unless if we feel like we have the time, or if this has been enough and we're like, wait a minute, I just have questions with what we have. I don't want to do the fire hose of mediation on everybody today. But if we are desperately curious about potential outcomes, or we feel like we're comfortable trying to play in that land, I'm happy to.
Yeah. We have one stats question and one general question on the chat. How are we feeling in the room? Okay. Yeah.
Yeah.
So the question we have in the chat is, could you expand a little bit on the issue of power for and sample size being a key piece here for some of the methods you've discussed so far?
Yes. So I would, again, when it comes to doing an actual study, I'm going to point you to Dave Kenny's site, because I know that I just looked at it last night. There are a couple of links to Shiny apps that will help calculate that power. There's another Shiny app called Web Power that will do that. So when it comes time to actually dealing with your numbers, that is a resource for you to go to. But I think what the question is actually about, this is a tiny, tiny portion of a table that I kind of cherry picked to just kind of show that Barron and Kenny method. For the most part, the rest of the table, the power or the sample size calculations kind of do exactly what you would expect, in that as your effect sizes get bigger, the necessary sample size gets smaller. So as you move, and typically if your A and your B paths are similar, you're going to have better power. So that's something to kind of think about. If you have like a really small A and a really large B, weird things start happening mathematically. Typically, if you were to go down further on this table, you would see the joint significance, the Sobel product of coefficients. There's the ProdClin, which is that asymmetrical confidence intervals, which you can do with the R-Shiny app that I showed you. And I think there's a bootstrap and a bias corrected bootstrap. And so all of those, many of those are similar in sample size. So like, I think this first column was in the 400s and 500s for all of the methods. When you get really large effect sizes, you can have as small as 30 to 60 people necessary for that. I'm glad this question came up, because the NIH wants people to look at mediation. A lot of times what I see is that mediation or moderation is the exploratory third aim, and nobody is ever powered to do it. Because they power on their first aim, they can only afford 80 participants, and they know that they're supposed to look at mechanisms. So my third soapbox is plan for mediation. Plan in your power analyses, plan for a mediation, if that is actually what you're wanting to do, if that actually answers your research question. And then no, you're not going to want to do Barron and Kenny, because you're probably not going to be able to get enough people to do that. So I don't know if how much that answers the question.
Yeah. So there's one other question which builds on what you were just saying about the NIH. Do you anticipate these types of analyses being required in grant applications and or network clinical trials as part of the analysis plan? That has not been something they've experienced in their current work with NHLBI.
Yeah, so I suspect that it might depend on the institution. I think some institutions might get to that point a little bit quicker. A lot of it's a two-edged sword, because I think that we should be really encouraging that we do this. I think it would be great if they required it, but that is coming from a position of bias, obviously. It's going to cost more money if everybody has to include a mediation, because it's just going to cost more money because you're going to need more people. And if your research question isn't about the mechanism, don't do this. Follow your research question. I wish everybody would do mediation, but it's more important that you follow your research question, because if this is a tack on at the end, you're not going to find the effect because you're probably not powered. And if you haven't really thought through the analysis plan, you're going to get dinged in a grant review because they're going to be like, oh, it kind of sounds like you know what you're talking about, but kind of not. So I would doubt that they would get so far as to be like demanding that, because it doesn't make sense with every research question. That said, I think it's a good practice to be thinking about it, because it might come up. It definitely might come up.
Would you recommend testing an interaction with the X and the mediator just as?
Absolutely, every time.
Okay.
Again, you're looking at an interaction term, so you're looking at numbers that are going to be very small, and so you may never be powered to find it, but I think you really should be testing it. And part of the reason is because that is a very crucial part of the potential outcomes or the causal inference methods. And so, yeah, I absolutely would. It'll probably never be significant just from pragmatic history, but you should do it. Yeah. Okay. Especially if your research question or your theory suggests that there could be an effect.
Okay. Do you want to spend a couple minutes on potential outcomes?
Yes. This will be the fire hose. There's going to be more here than I think it will be reasonable to expect people to like really grab onto. But I think it is so important that you at least be aware of it. And I'm happy to stay after to answer questions. Let's go. Everybody buckle up. Okay, so the potential outcomes. I want to just kind of think about this fundamental problem that we have. So in reality, I'm going to bring a bunch of people into a room. I'm going to recruit them. I'm going to randomly assign them to take either the white pill or the black pill. And then I'm going to assume, because they've been randomized, that they're basically exchangeable. And so I'm going to compare the mean of the first group and the mean of the second group and say that this pill versus the placebo causes insane purple hair growth, like immediate purple hair growth. I don't know. But let's be honest, we had two groups of different people. We don't actually know whether that pill caused it, or we didn't get a good confounder. We had unhappy randomization, but that's the reality of what we can do. But imagine if we took just one group of people and we gave them the placebo and they took it, and nothing happened. And then we get into a time machine and we go back into time and we switch out the pill bottles, and instead of the placebo, they get the active treatment. And then all of a sudden they have long, luscious locks of purple hair. Because we are testing the exact same people at the exact same time, there's no like, you can never step in a river twice type of philosophy, because we used a time machine. We would know exactly the causal effect of that medication. You can't do that. Holland told us back in 1986, you can't do that. It is called the fundamental problem of causal inference. And so the fuddy-duddies who don't like to talk about causation, will love to say, but you can't do the one thing that would allow you to say that you have a causal effect. But we are ingenious. We are an ingenious species that insists on trying to push the envelope of our knowledge. So we're going to say, well, we can't build time machines, but what's the next best thing that we can do? We know that philosophically, what we want to do is compare what we actually see, this group of people who were given this particular medicine, versus what we don't see, this particular group of people, if they had not received the medicine but had gotten something else. That is the observed reality and unobserved counterfactual. And then we have to add, this is the key, all of these identification assumptions that will allow us to be confident in inferring that that difference is truly the causal difference. So remember earlier I said, like, be on top of your assumptions. Know what it is you're assuming when you do a model. So a lot of people go, well, if you can't see it, how can you test it? The secret sauce are all of these causal assumptions. And I want to bring this kind of back a little bit. This was the model that we were working on, and we were saying, let's look at whether X is related to M, and let's look at whether M is related to Y. Well, if you think about it, if X is randomized, then we can feel really good that the path between X and M and the path between X and Y can be interpreted causally. We randomized X, that is the gold standard, that's the closest thing we can get to the time machine. And so most people would say, okay, those two paths, we can say that they're causal paths. But what about M to Y? Randomizing X does not mean that M is necessarily balanced. And therefore, that M to Y relationship, that path, we can't call that a causal path in that traditional product of coefficients framework. So the problem that we have is that confounding specifically of that M to Y relationship. If X is not randomized, you will have the same confounding issues with the other paths, but we're assuming that X is a randomized intervention. There are some study design techniques you can do, like the sequential or concurrent double randomization. These are going to be expensive because you're basically running studies twice. It's better than nothing. There are some statistical things that you can do, like sensitivity analysis, inverse probability weighting, sequential G estimation. Those are things definitely like go talk to your analyst and say, please tell me how to do this. Those are a couple of ways that we can try to deal with this confounding. And there's going to be some more assumptions that you'll want to take care of. And that's why if you want to go down this path, it should be a very intentional, thoughtful thing, and surround yourselves with some people who are familiar with this topic, because you're going to have to talk about all of the assumptions we mentioned before, plus the stable unit treatment value assumption. I know it looks like a mattress company, that's Satva, but it's Satva. And honestly, these assumptions are good even in a more traditional analysis. You're assuming that if I treat you, that doesn't affect how your outcome is. So it's like if you give one kid a candy cane, does their sibling who live in the same household have a behavioral outcome? Well, yeah, those things are overflowing. That's not a good, no longer a good experiment. We assume that if I'm giving somebody a treatment, that everybody is getting exactly the same treatment. These might be like dosing issues. Obviously, we assume that everybody can have the treatment. If we're looking at a treatment for prostate cancer, we assume that the people in the study have prostates. And if they don't, they have a zero probability of the outcome. And again, the exchangeability, which talks to that confounding issue. And so this is just kind of lists all of those design and statistical ways that we could address potential confounding. There's some software packages. If you're interested in, I want to make sure I give you something tangible that you can work with. I personally have not tried CMA-verse yet. It is fairly new, but it seems to incorporate like these R mediation packages. So if you're an R person, check out CMA-verse. but you can do all kinds of causal mediation with these packages. So this is something you can even take your analyst and say like, hey, which one of these programs do you use? And what can you do for me? If you want to get into the weeds, send me an email. I'd love to talk more about whatever details. And there are some suggested readings at the end. So.
Thank you for a very quick but thorough introduction
It's hard to do
to potential
both.
outcomes.
It's hard to be quick and thorough.
All right. Yeah, we can absolutely clap. You don't have to. I want to thank everybody who's in the room, and for those of you on Zoom as well. The link for those of you on Zoom for the evaluation is in the chat. And I believe there are paper evaluations floating around for those of you here in the room. Please let us know what you think. We also have time for one more question if there were any lingering thoughts or confusion on this last bit. Okay. All right. Well, thank you. Yeah. Let me run back here.
Again, on the last bit being very quick.
Yes.
Conceptually, then, are you talking that this is really a design issue, or is this a statistical issue that I'm managing it, or is it both?
It is both. There are statistical concerns that you need to think about, and the best way to handle those concerns is through your design. So.
If my design assumes a spillover effect to others
Mhm.
as part of the design,
Mhm.
then I just need to think about that implication in the design.
Yeah, so you would think about times when there is spillover or not spillover, and the not spillover might be that unobserved counterfactual condition. And I assume that you might be looking at clustering, like mixed, not mixed methods, but like mixed effects models or multi-level models or something to deal with clustering as part of the spillover.
Yes, and no.
Okay. Yes.
All right. Well, thank you all so much for coming, and thank
Yes.
you, Dr. Smyth, for a wonderful talk.
My pleasure.